Okay. Good morning, good afternoon, everybody. Thank you so much for joining our 16th webinar in the UG2 series. My name is Georgia Coward. For those that don't know me, I am the UG2 coordinator based with the Center for Ocean Leadership at UCAR. Cassie Wilson, my colleague, is also based with Center for Ocean Leadership, and she's on the call. And Bill, who was the previous UG2 coordinator, is also here. So thank you so much for joining today. Today's webinar is going to focus on data management, which is a very big topic to try and squeeze in. So I'm very grateful to our two presenters today for volunteering to run through some data management 101 and some glided DAC specifics, and then provide plenty of time for some questions as well. So very briefly, sort of the plan for today's webinar, I have a few UG2 specific updates to provide, but I will keep them brief, and then we will jump straight into data management presentations and Q&A. So I want to start by thanking Jennifer Bowers and John Kerfoot, who are presenting today, and will be there to answer all of your data management questions as well. And then I will spend just a few minutes at the end wrapping up on some UG2 business. So as always, I just want to give a great shout out to our steering committee that are working tirelessly behind the scenes, particularly this year for the workshop. We have a really representative steering committee all across the United States, from different sectors and fields and locations. So again, a huge thank you to all the work that they put in to keep UG2 running, particularly this year with the workshop. So that being said, it's a great segue for me to promote the workshop. I'm sure a few of you have already seen the sort of save the dates come out. For those that did come to the Ocean Science meeting in February in New Orleans, we did have some save the date postcards. So we are planning our workshop for September, the 10th to 12th, and it will be taking place in Ann Arbor in Michigan. We're working very hard, but plan to open our call for abstracts and registration in April, which, believe it or not, is coming up very soon. So please do keep your eyes peeled for those emails and messages that will come from us with the registration information. As I mentioned previously, we will have some funds available for early career, particularly to support travel as well. So please do apply, do tick that box if you do need some financial support to enable you to attend in September. So lots happening with that. Key date at this point is April, when we will open that registration. There's also the EGO workshop. I'd like to give them a shout out. That is happening in June. It's taking place in Sweden. I believe registration might still be open for that, so do check that out as well. And then I do just want to flag as well, we had a fantastic UG2 town hall last month at the OSM in New Orleans, and I have shared already on Slack the sort of report out for that. It was really well attended, it was really fun, and we had a really great group with some great questions. So please do check Slack for that report. Otherwise, you can always email me if you'd like a copy as well of that report. And as always, there's other documents that are available, including workshop reports from 2022 and some workshop briefs. For any of these, they are shared frequently through Slack and MailChimp. But again, as I said, just reach out to me via email if you do want a copy of anything. So with that being said, I am very excited to introduce our presenters today for the data management webinar. And I will pass on to Jen to get her screen ready. So Jennifer Bowers joined NOAA in April 2021 to coordinate the NCEI Uncrewed Systems Data Enterprise, and she serves as their lead Uncrewed Systems Data Coordinator. Currently, she leads a team that is partnering with the Navy to develop NOAA and Navy data exchange standards under the Sea Note Act of 2018. In addition, her team is researching the use of innovative technologies to build a framework for the uncrewed systems data enterprise by developing specific data use cases. Jennifer came to NOAA with over 20 years of experience providing naval oceanography support. And finally, Jennifer is also a very active UG2 steering committee member, and she also leads the UG2 data management sub-focus group. Over to you, Jen.
All right, thanks for that, Georgia. And again, I'm glad Zoom is not my platform. So can you confirm that you can see my slides? Because I cannot see them. Okay, great. Thank you. Appreciate that. I'll be presenting on behalf of the UG2 Data Management Steering Committee, and my partners' names are listed here on the slide as well. And we'll just get started. We've got a lot of material to cover, and we're going to start big and kind of give you that big picture look and why you want to engage in data management activities. And then the second talk today, we'll start to talk about some of the details involved with data management. Here at NCEI, we support the glider DAC and the initiatives that they're doing to make life easier for everybody when it comes to data management. So I guess we'll start by starting at the very beginning with what is environmental data. Sometimes with large groups like this, not everybody's on the same page. So let's put you there first. Environmental data are measurements or observations that describe the Earth system. I'm an oceanographer, so I naturally think of temperature, salinity, bathymetry, weather. At NOAA, we also do space weather, a variety of electromagnetics. So there's a lot more information, but today we're going to focus on that which is collected by gliders. By federal data policy, all NOAA programs are required to share their data in a timely fashion, except where it's limited by law. There's a few exclusions for that. And it's important from a data sharing perspective to mention that NOAA is not the only organization that requires data sharing. The National Institutes of Health, National Science Foundation, the NASA, Department of Defense, federal data sharing is something that's required when you're receiving federal money almost across the board. So I work for NOAA, I can speak for NOAA, but I know that these other organizations do as well. So I'll just put that out there. Now, it all kind of starts with you, working with people like you. NOAA has been increasing the use of uncrewed systems to collect real-time data and your real-time data in a variety of environments, especially those that are traditionally difficult to measure, under ice for months, in the middle of hurricanes, long duration video surveys, that sort of thing. But I wanted to let you know for the rest of this presentation, that little blue icon represents people like you, the data collectors or the data collection community, and you'll be popping up through the rest of this presentation. The next person that I want to introduce, little marker here, is the green icon. And I'll be speaking on behalf of what NOAA's National Centers of Environmental Information do for you. That's NCEI. We are a federal data archive. What we do with the data that you collect is we quality control it, we apply the FAIR principles, build interoperable data sets so that a lot of different people can use them for more than its first intended mission. That really extends the value of the taxpayers' investment in the data that you are collecting. And we do make all the products as available for public use as possible. Sometimes there are a few exceptions, so a nod to that. And I'll step back again to talk about why data is so important. I don't know if you've ever heard this saying or not, so I'm going to put it out there, make sure everybody's aware. Data is the new oil. This has been said around the data management communities for quite some time. It's attributed to a British mathematician in 2006. But we can take data and build from it. We can build information, knowledge, and wisdom. The idea with this graphic is to not to impart to you the value of data itself, but to impart that data needs to be refined to make it more valuable. So when we curate the data or do a variety of data management steps, we increase the value of that original data collect as we move up from data to information to knowledge and decision making. So just keep that in mind when you're out there collecting it. There's always another use. In a knowledge-based societies, data is what leads to success. And when your data is reproducible and your processes are well documented, that creates a lot of trust in the decision-making process. That's how we can take research and operationalize it for making decisions on weather forecasting and things like that. To the protocols that the glider community works on to put in place the best way to collect underwater temperature and salinity for feeding weather models. It's very, very important, the work that you do. I don't want to miss that connection at all. When data is properly curated, and these steps involve all of us, data and environmental information products can lead to large societal and economic returns. Hurricanes is a good example, but also within fisheries, we collect a lot of data that gets refined over time and works to feed our nation. So there are a lot of really amazing things that are done with glider data. And this is an important part as well. When data are used as a resource for follow-on products, right? When someone else can use your data to do another product with it, to make something else out of it, the work that you've done really becomes an indispensable asset. And usability is what gives data power. The real power from data comes when we can share it between each other and across the community. So thanks for that. Data is, I've talked about refining data. I just wanted to let you know a little bit more what that looks like in case you're not familiar with the data management lifecycle. Data refining happens through data management processes like this color wheel that I have here. It's the practice of collecting, keeping, using, securing, and handling data in efficient and cost-effective manner. This is very important as a lot of our organizations are moving into cloud computing. We really have to be smart about how we're handling the data and how we're working together to pass the data along from the collectors to the data storage facilities and data reusability people. Data management includes things like how you store your data, different file types and metadata, processing and integration. These are all pieces of the data management lifecycle. And it goes without saying, some folks only work in one sector of the data lifecycle. Some folks may not do anything other than collect data, and that's great. We really rely on them back here in the archive where I work to collect that data and do a lot of maintenance on that to get it to us for archival purposes. But having a shared awareness that we all have a role in this, I think will provide better use of glider data as we move forward. This is a graphic that I like to include in almost every talk that I give. Where does the data come from? And the reason I like to put this out there is because I've been looking at graphics like this for 20 years. And I keep waiting for the day when the data starts flowing between all of these assets individually and easily. There's a lot of IT problems. There's a lot of data format problems. There are a lot of data metadata problems that need to be worked out before this can actually be realized. But that's what we're here to talk about today. And again, we're going to focus on the glider data. So you are here. What does data management look like? It can look like a real tangle sometimes. It involves a lot of people, quite a bit of policy, numerous processes that are guided by high-level data governance, as well as the individual processes for quality control and quality assurance, metadata tagging, doing the things that are necessary to access the data on the back end. It takes a whole lot of work to make data interoperable. So this graphic is sort of to give you a picture of the complexity there. It makes some people panic. The first few times I've seen things like this, it has made me panic. When I walked into my job at NCEI, I thought, oh my goodness, how are we going to do this? But it takes a community working together. And fortunately, we have communities of practice like the Underwater Gliders group to help pitch in and work together to get this done. So there's no need to panic. We just need to walk through those steps. If we take it one step at a time, data management is it's comprehensible. It's something that we can do if we all understand the different roles and responsibilities that we play. So let's get started. And I'm going to pop the center out of that data lifecycle, and we're going to walk around that circle. So remember the data lifecycle that I showed you in the beginning. As a data collector, it starts with you. You have a glider, you have a mission, and you have a collection plan. There's a lot of variability in the missions. There's also a lot of variability in the collection plan. We know that you know what you're doing. We're excited to help you and support you in your mission. NOAA's got a variety of missions that a lot of folks are out there collecting data for. So it always starts right here in the collection space when I'm thinking about it. The next step is you need to organize and store your data. Some folks have challenges with that, but we want you to remember that you're not alone. The Underwater Glider Group is here for you. There are several glider DACs that are available to support discussions to help you figure out how best to organize and store your data so that we can share it across the communities. And UG2 has got a great Slack channel. If you're not a member yet, log on, sign up. They love having new people come on into the community. Here's a couple of the glider DACs that exist. IU's has got the National Glider DAC, and John's here to talk to us today about some progress and things that they're considering in development on their end. And there's IMOS and EGO. All of these organizations have data provider tools and metadata standards that are available. And they also offer data visualization and data access activities that you can tap into. So you're not alone. These folks are here to help you when it comes to organizing and storing your data. And that should make you happy. All right. The next step in the data lifecycle is using and analyzing the data. This one's very tricky. It would take a dive down into the different communities of practice on these, so we're not going to go into that today. But you would process your data using the protocols for your science mission. Some folks are bathymetry, some are doing currents. We're going to keep it kind of in the realm of the glider DAC. So we're looking at those physical oceanography properties, temperature, salinity, density, that sort of thing. There's weather predictions, fishery studies. I guess we got the picture there. The next step in the data lifecycle is getting ready to share that data. And again, this starts with you. But remember these people. Don't forget, these guys are here to help you. If you can get your data into one of these data assembly centers, we're going to really be able to tap into that complex data lifecycle that I had shown you earlier. Organizations like NCEI, various environmental data archives, work with teams at the glider DACs to bring this kind of data management to your fingertips. So sharing the data that you collect with the glider DAC makes your data available to weather services through the GTS. It makes your data available to the NCEI archive. We can preserve your data for 50 to 75 years and make it available for other folks to tap into with their missions. It's incredible what happens when you get your data to the archive. Traditionally, it's been thought of as the end of the road, but really it's sort of the rebirth of your data. It's where it starts its second career. So I know scientists, I took this job because I wanted scientists in the future to have access to the data that we've been collecting way back here in 2020 to 2024. I think it's a good use of people's time and energy. I would have loved to have had a healthy, older data set when I went to graduate school, but just wasn't the case at the time. So I do recommend data sharing. It helps everybody. The next step in the data lifecycle is archival of the data. Archival of data that is federally funded, it's imperative that you do this. All of the funding organizations do require that. So this is one way to automatically make that happen. Sharing your data with the IU's Glider DAC will automatically pipe that information over to the NCEI archive. As long as we're meeting those standard formats and metadata standards, things flow significantly easier. I do get emails whenever there's a failure, so please spell things right, tick the proper metadata boxes. It's not too tough once you've been walked through the process. NCEI makes data available to the public to support future scientific research, as well as available for fairly near real-time applications. It depends on the speed to which we have the data flowing from folks. Upon archival at a federal archive like NCEI, your data reaches that start of a new beginning, it gets reused. And I just wanted to reinforce that usability, the standardization, standard formats, standard metadata, that's what gives data a whole lot of power when folks are using your information to figure out if they want to go surfing, when is the best time to hit the high seas, or if they want to study hurricanes or fisheries, scallop farming. There's a variety of uses for your data moving forward. And I'm not just going to tell you, I'm going to show you. I'm going to show you what we do at NCEI with it, because we use it too. The public has access to that information, which is great. All the universities and academics can come into NCEI and pull that data from the archive. But NCEI itself, organizationally, we have teams of scientists available to contextualize the data that you've collected into a variety of products and create very long-term climate monitoring projects. Everybody's always talking about, well, how do they know that the climate is changing? Well, folks like you have shared your data across time, so we're really starting to develop a very healthy picture of that climate change. I'm going to shift gears here a little bit and talk about some of the Ocean Climate Labs work that is done at NCEI. And I'll tip my hat to Tim Boyer over at NCEI. He's the head of our subsurface oceanography section, and he's responsible for a lot of the work that you see here. Data comes in from you, starts with you, you're number one. You're part of the ocean observing community. You're out there collecting data with the gliders. Step number two, hopefully, this is what we hope you do, submit your data to one of these glider DACs. John here is here to help you with that kind of stuff today, some of the details. And after John's got that, what we do is we apply the FAIR principles, make the data, we quality control it, give it a uniform format, and we make it available to the general public after we've done that for you. And then we'll take it a step further. Sorry. We'll take it a step further. We'll enhance it, and we will turn it into authoritative information products. So we'll take the data that you've taken off of the coast of New England, and we will put that in context with data that people have taken off of the coast of Virginia, and we'll start to draw the ocean climate along the eastern seaboard. And we can add all kinds of data across a variety of time and space scales to generate very healthy regional climatologies. And that is thanks to the data that you're all sharing with us. We calculate things like global ocean heat content, salinity anomalies. And when we contextualize that data, put it together over decades of time, we're able to build integrated ocean climate information products to kind of document that change over time. So we do have products that we put out on continuous cycles. The next slide I have to show you, again, it's another NCEI product. I really like this one because it shows you what's happening with the World Ocean Database. I know a lot of the glider community uses World Ocean Database to pull information and add value to their own science products. But you can see over time, this graph starts in the early 1900s and it runs up to 2020. We have over 17 million profiles from 90 countries that crosses a time span from 1772 to present day. The data comes from a variety of different sources. There's ocean data from the Niskin models. Hopefully everybody's been out on a cruise and done that, because that's a good time. You've got the different XBTs and your traditional seabird CTDs, bucket only, right? The 1772, that would have been some of the bucket data that was taken on Captain Cook's second voyage. They were able to recover that data and get it integrated into this database product. There's a variety of moorings and floats, but the gliders here, this teal color down at the bottom, when you look at what's happening over time, you can see the colors changing. The color bars start changing over time. And gliders are contributing a significant portion of data to the World Ocean Database these days. And you'll notice also that there's almost an exponential increase between 2002 and then 2004. It really kicks up. And that's because you've got all these electronic and digital systems coming in and providing more and more data at faster rates. And we're seeing improvement in compliance with data management activities as far as standardization and metadata tagging. So again, thank you to the community that's been out there collecting that data. This is your data set. The World Ocean Database belongs to you. And we thank you for contributing to it. Another graphic that I like to show is some of the spatial distribution of the data that's collected in the World Ocean Database. And I do like to let folks know that more than 30% of the data is from gliders these days. And in 2020, it's probably 50% of the data. Half the data these days are coming in from gliders. So it's really an increasing data collection asset as far as our ability to monitor the ocean temperature. And again, I would point you to NCEI's Tim Boyer. You can Google him. He's easy to find online if you've got any detailed questions about the World Ocean Database. And I will leave you with this slide, and it's kind of got the three high-level parties that are involved. That's you, that's the various glider DACs, and that's federal archiving organizations such as NCEI. From my point of view at NOAA, this is our vision. The real power of uncrewed systems data is going to be realized when the data that is collected is shared as massive sets of big global data, and then we're able to analyze those with big data techniques using artificial intelligence and machine learning to pick out some of those patterns that we have not seen before, or that we can't even approach when data hits these types of volumes. And the community enablers for this are you, data sharing, data standardization, and robust metadata. So I think I'm going to stop speaking here. Hopefully I've provided you with an idea of why we want you to continue to contribute, and why we support you in getting your data needs across the field. Georgia, did you want to jump on in here?
Yeah, just to say thank you so much. That was, yeah, really great. I think it's nice to see it so clearly laid out. So thank you. I appreciate data management is a very overwhelming topic, and you've made it digestible. Whilst John gets his slides set up, I would like to open this up to any questions from anybody in the audience. You can either unmute and then ask the question, or you can put something into the chat. But are there any questions for Jen? Okay. And if there's some that you want to ask, we will also have plenty of time for questions after John's presentation as well.
Sorry, can I ask a question?
Of course, Huey.
Yeah, thanks for the great talk. And this might be covered in this one too, but I just kind of wanted to see what the status was for biogeochemical parameters getting into the glider DAX and then ultimately into NCEI. I assume most of those profiles are temperature and salinity. And so, but there are a lot of oxygen, chlorophyll, backscatter, et cetera, and then more and more pH and nitrate coming up. And I'm just wondering what the status of the data system was in terms of accepting those standardized data formats, et cetera. Anyways, any comment on that would be great.
Yeah, there are different routes to getting your data into NCEI. So we can pull data in through a couple of different sources. We do like to integrate with the glider DACs. So I will kick the ball over to John and let him answer or address when they believe they'll be implementing those sorts of things.
Yeah, so I'll give you a little bit right now, and then we can follow up a little bit later. So I think as far as the IU's glider DAC is concerned, so our focus going back years, and I'll give you a little bit of history on that here in a minute, but really had been focused on temperature and salinity profiles, right? Ocean circulation and weather forecasting and all that kind of thing. So that's where we were really focused on in the beginning. As this system has matured, and as the community, all of you have done such an excellent job sort of getting these gliders into the water and integrating new instruments and working with the manufacturers and the instrument manufacturers. Obviously, there are a ton of new instruments that are onboard gliders that are flying right now. And the way that we set up the initial format and specification for the IU's glider DAC, and I'm pretty sure it's this way for IMOS and EGO as well, is the format that we use is really essentially a time series format. So any measurement as it stands right now, any measurement in which you've got a time, a depth, and a parameter measured in sort of a tabular format, you can include that right now without really letting us know, and we will pick that up and we will serve that in these data sets, and those will be included in the data sets to go to NCEI that are archived. So we do recognize particularly things like ADCPs, and there's a few other instruments out there that maybe aren't as standard in terms of a tabular sort of layout within a NetCDF file. We are aware of that, and I would say if there are particular instances or groups out there that are like, look, I've got data and it doesn't look like it's going to quite fit the way that you have things set up right now, let's have that discussion, because we're certainly open to, and our intent is to be able to support and to be able to include essentially any measurement from any new instrument that comes on board here, now sort of going into the future.
Okay, thank you.
Great. So we will move on to John. And then, as I said, there'll be plenty of time at the end as well for some questions. So it's my pleasure to introduce John Kerfoot. John graduated with a Master of Science in Biological Oceanography in Marine Primary Production from the University of California at Santa Barbara in 2000. He began working for Rutgers University Coastal Ocean Observation Laboratory, RUCOL, in 2001 as an ocean-going field and instrument technician. RUCOL took delivery of their first 2 Slocum gliders in 2002, and John led the field trials and testing efforts for these vehicles. Since these trials, the RUCOL fleet has grown to over 40 Slocum gliders and continues to grow with deployments now around the globe. For the last 15 years, John has assumed the role of the Primary Data Management Officer for RUCOL, processing and disseminating a wide variety of data sets spanning biology, physics, satellites, and the environment. During this time, he has contributed to a wide variety of local and international projects, including Maracus Regional Association, Ocean Observatories Initiative, New Jersey Department of Environmental Protection, and hurricane forecasting efforts. He is a primary designer, contributor, and subject matter expert for the IU's Glider DAC Assembly Center, and serves as a member of the Ocean Gliders Data Management Task Team, where he's in charge of the development of the OG 1.0 Glider NetCDF specification. Over to you, John.
All right, thank you. So we're good on slides. You guys can see the slides?
Yes, perfect.
Okay. All right. Thank you, Georgia, and thanks, Jen, for that presentation. I think it's good. As you sort of mentioned, and as I think we're at a really sort of critical time here, where I think we've passed this idea of proving that gliders are, you know, an economical and sustainable way to monitor both short-term and long-term processes in the oceans, you know, places where we may not have always been able to get to or monitor with the consistency that we wanted to. So, you know, the gliders are a proven technology. And so we're at a point now where, you know, as Jen mentioned, we're getting a lot of this data coming in. And really what we want to try and do now is provide the community with, you know, a set of tools and you know, essentially a data assembly centers that will allow you to get this, to allow us to collect this data, standardize it using, you know, all community accepted sort of specifications, control vocabularies, you know, standard names, units, those types of things, so that, again, we can, you know, not get hung up on how are we going to exchange data across the DACs, but just we've got these DACs that are all doing their own thing, which is fine. They've been doing these things for years and years and years, and let's just provide a way so that we can minimize somebody having to rewrite the, you know, reinvent the wheel here on how am I going to access this data if I'm going from ego data to IUS data or to whatever. So I'm going to talk a little bit today about the alignment of the IUS Glider DAC and the Ocean Gliders 1.0 data format, right? So with the overarching goal of creating a global standard for the international exchange of glider data sets. I have listed here sort of the IUS DAC team as it's currently constituted. There are a number of other people over the years that have contributed, and, you know, we're very grateful for those contributions. So quickly, what I'm going to give you an idea of what we're going to talk about. For those of you, we've got a pretty international, I think, group here. And so I do want to provide a little bit of a background, I think, on the IUS Glider DAC and what we've developed and what we've been using for, you know, a little over a decade now. And then sort of transition towards, given what we're doing here at the DAC, we're one of three DACs. There may be some others, but, you know, Jen mentioned them, EGO and IMOS and the IUS Glider DAC. What has come sort of online here in the last couple of years is this creation of the Ocean Gliders Data Management Task Team to come up with a standard exchange format, right? And so it's building upon the lessons that we've learned over the years, that the individual DACs have learned over the years, to create another NetCDF format, which, again, I think the take-home message really is that it's not a whole lot different from any of the three formats that are currently being used. There are some differences there, but we don't see any roadblocks that'll prevent us from achieving this goal of a format to sort of, you know, unite all of the DACs. So we'll talk a little bit about existing standards and conventions and how they've been used from the individual DACs, and then how those have been considered for the OG 1.0 format. A lot of this really is a lot of the big differences or additions, or what really will enrich these data sets, are these metadata requirements. And so we are working on trying to develop ways that we can provide you and the DACs as well with the ability to sort of make these modifications, add metadata to really complete the data set, you know, and make it much more useful to those of us that are out there using it in our research. And then we'll talk just a little bit about sort of what we see as data provider responsibilities going forward, potentially the IUS DAC responsibilities. And then I'd like to get some, you know, feedback from from you guys on sort of how we can make this easier for you. All right, so briefly for the IUS Glider DAC. So the IUS Glider DAC, we started sort of kicking this idea around for an IUS Glider DAC early, you know, 2010, 2011 or so. Around 2013, we began construction, and sort of that was two pieces. It's really sort of designing a format, a simple format, and submission process for the data providers that provides data, collects and provides data access via existing web services in a variety of well-known formats. Primarily, we're talking mostly about ERDAP and threads, because from these two data servers, you're able to get things like CSV and JSON and NetCDF and MATLAB files and all of these things that we're all used to kind of working with, right? The overarching and primary goal really was to facilitate the distribution of data sets to the GTS, right? So we've got all of you are out there, we're all dropping gliders in the water, we're getting the information back, we're storing it in our own formats, and then if I need it, I email somebody, they send me their NetCDF format or their CSV zip file. I take that, I kind of, work with it a little bit. But what we really wanted to do is be able to get this all in one spot, standardize it, make it consistent so that we could then start down the road of getting this information released to GTS for things like model runs and ocean forecasting and those types of efforts. And then we're also working, as Jen had mentioned, with NCEI on providing a permanent data archive. As she had mentioned, there are requirements from a lot of the funding agencies that, this data needs to be citable, it needs to be accessible, it needs to be what we'll call permanent. I don't know that anything is permanently permanent, but certainly, somewhere where you provide a link and then when somebody goes, they don't get a, 404 on that because they can't find the data because it's been moved somewhere. A bit of a busy slide here, but essentially this is sort of the breakdown of how the IUS glider DAC works. So you've got three sort of pieces. We've got data providers, right, which are out there deploying gliders, collecting data, getting it into the IUS NetCDF specification, and submitting that data to the DAC. Once the data, this is right now, it's via FTP. Once this data is submitted, we then do a whole bunch of, sort of magic stuff here using primarily ERDAP. ERDAP does a lot of the heavy lifting for us in terms of aggregation, standardizing a lot of the metadata across the data sets. We are working, you can see a box here on some QC that we're currently sort of developing and working on to apply a consistent set of QC flags to this data for use by, let's say, NDBC when they're going to figure out what they want to release to GTS, or if you as an end user want to say, okay, I want, I would like to run through some of these QC tests to mass some of this information out because I'm curious about some sort of granularity of, how accurate the data may be. Regardless of what happens there, we're then aggregating via ERDAP. And then the public can access these data sets using, I think people are mostly using ERDAP. I didn't put threads on this slide, but threads there are also threads endpoints. And you can come in there and, if you're familiar with ERDAP, I think ERDAP's becoming fairly familiar to a lot of people in terms of a data service. That will allow, anybody to come in, access the data in a variety of formats. Those formats either can be used for the NCEI archival process or GTS, released to GTS by NDBC, or you as the end user in your individual research projects. Okay, so quickly here. So this is, I created these, I think, a couple days ago. So this gives you an idea, particularly the plots on the right here. So you can see as years have gone on, and this is all to you guys, to the community. You're the ones that are submitting these data sets. You're the ones that are putting this work in. A lot of times there may not be a requirement to do it. And so we do very much appreciate everybody taking the time to walk through some of the stuff. We do recognize that, I say a simple format and simple submission process, but there certainly are hurdles there in terms of NetCDF and metadata and things like that. But we found that the vast majority of our data providers have been very good, have asked a lot of the right questions, have done a really good job at getting that data together, collected, described, and then ultimately submitted to the DAC. So you can see here, we've got, we're increasing every year with the number of data sets data sets that are submitted to the DAC. From those, we can pull out things like glider days, right? So in 2023, across all of the gliders, we had gliders in the water for a total of over 11,000 days, which, I mean, to me is really impressive. And that number, we don't see any reason why that number, won't continue to increase. Just a sheer sort of volume of profiles. Jen was talking about how the numbers really increased for the World Ocean Database and what comes into NCEI, and you can see that reflected here as well. 250,000 profiles a year or over 250,000 profiles a year for the last 4 years. And again, I think that, you know, that will certainly continue here. The IU's Glider DAC, this is sort of just a rundown of what we've got. So we sort of break these data sets into individual categories. We've got real-time data sets. These are ones that help us track down if there's a problem with the data set, how we might go about fixing those issues in terms of getting it displayed on ERDAP and ultimately archived. We're currently around 1,800 total data sets. That's real-time and delayed mode, right? So real-time is gliders in the water, probably a low resolution version. It may be decimated, but we also have delayed mode data sets. When the gliders, you know, come back, those flashcards are pulled. They're higher resolution. They're typically not decimated. So it's a combination of you know, those two different types, right? And then once we've got all this information and we've got things running on ERDAP and we've got the data sets available, I just created a few heat maps here that sort of display the same data as before by years. Here, these are just heat maps that sort of give you an idea on glider activity by year and by season, right? So many of these data sets from, let's say, 2013 or 2012 back, these are ones that the DAC wasn't up and running yet. They were submitted afterwards. But you can see that from about 2013 all the way through today, the number and sheer sort of volume of the information coming in, it has really, you know, sort of exponentially increased. Of particular note, you can see, you know, seasonality wise, at least in, you know, the Northern Hemisphere, things really pick up sort of in the, you know, spring and summer. I think a lot of that is probably coordinated to a lot of the hurricane forecasting efforts that have been undertaken here for the last 5, 6, 7 years. And a lot of you are involved with that. And again, we really appreciate, you know, the time and the dedication that you guys have shown to doing that. It's really, I think, made a really big difference. And again, it really illustrates the importance of this work and the importance of sort of where we're going as a community. Okay, so to sort of finish up a little bit here on the DAC. So once the data set has been submitted to the DAC, we do have a status page that I think was released a couple years ago. The idea behind this was to provide you, the data providers, with an easy way to go take a look at the status of your data set, right? What's the name of the deployment, WMO IDs, how many profiles do we have, how many days has it been in the water, the coverages, right? So the coverage starts, you know, here and then green, obviously green is good. So in this particular screenshot, these are data sets that have updated within, I believe, the last 24 hours, right? So this is completely searchable. You can search by status, glider, provider. There is an API also underneath the tools menu that allows you to essentially make requests, you know, get requests, and get this information back as JSON, GeoJSON, tracks, you know, things like that. So if you want to sort of build your own app or build your own sort of status to help you, that we've provided those tools and they're available for you. Clicking on a particular data set here will pull up a status page for that data set that just provides you some more of that information, really kind of gets a little bit into the details of the metadata. Quick links here to access the DAC, the deployment registration page, the ERDAP data sets, you know, plotting, data set descriptions, things like that. So again, the goal here is we don't want this to be a black box. Like, we don't want to just say, give us your data and then we'll let you know what's going on with it. We're really trying to provide as much feedback as we can to you, the data providers, so that you can, one, start to sort of diagnose maybe what you see as might be problems that you can fix or suggestions for us on how, you know, things might be going wrong. Or if we get an email from somebody saying, hey, I submitted this data set and it's, I don't see it showing up. Then we have a place to at least start and sort of investigate, okay, what maybe are the issues? Typically, the issues we see are really with the NetCDF specification and ERDAP tripping up on issues or errors in how those files are constructed. Again, you know, once Jen talked about this, but We also are providing, our NCEI has graciously helped us provide what we'll call a permanent archive, right? So every data set that gets submitted to the DAC, once it's been marked as complete and it's specified as we would like this to be archived at NCEI, the data gets shipped there, or NCEI comes and pulls it, provides a permanent archive of all versions of the submitted data set, provides an accession number, which is really a permanent, citable reference to the data set. So it's, for all intents and purposes, as far as I've heard, and if I'm not correct on this, please correct me, but this does seem to suffice when you're getting requests from funding agencies to, hey, we need a citable reference to this data set. Those we call them accession numbers. When a data set gets added to the archive, it gets assigned a new accession number, which is unique. If you then go back and say, this is the real-time data set, but I recovered the glider, I have all the delayed mode, I'm going to reprocess the delayed mode and push that, it then is archived under the same accession number, but the version number is incremented. So what you're left with when you get to NCEI is really an audit trail of that data set, from real-time to delayed mode to, oh, I submitted the delayed mode, but just last week I came up with this great, fantastic new set of QC tests, and I'm going to run those, and I'm going to submit it again. You'll see a version 3, right? So version 1, version 2, version 3. So it allows you to sort of, depending on what your use case may be, say I'm just looking at real-time data or delayed mode or super QC delayed mode. All of that information is there, and again, is citable and essentially, we'll just call it permanent. I think Jen said it was on the order of 50 to 75 years. So, it's a really nice way to archive the data. All right, so that's what we're doing with the DAC, what we've been working on at the DAC for, again, a better part of a decade, a little over a decade. And so the next question, and what we've been discussing, internally and talking with, ocean gliders and some of the other DACs out there, are, do we really need another net?
John, we may
There
have
will
lost.
be changes, and there will be things that we need to modify and that we're not doing now that we may need to do. Sorry, can you guys still hear me? I just got my internet connection is bad.
Yeah, it cut out for a second, but we can hear you now.
Okay. So, the decision, was made by the Ocean Gliders Data Management Task Team. Again, this goes back years. I'm pretty sure, I don't know the exact year, but with sort of the goal of coming up with a format that, again, won't break any existing processing or data assembly centers. It'll be community guided. It'll result in the creation of a single standardized format that incorporates existing and accepted community standards and formats, right? So we talked about the three sort of DACs, EGO, IUS, and IMOS. Those DACs came up with specifications based upon a lot of community accepted standards, things like CF, COARDs, control vocabularies, standard names, that kind of thing. And so we're not doing anything that is new and not, I would say, accepted by the community. And that is really on purpose, because we don't want to cause, we know that there will be some headaches, but we want to sort of minimize that, right? And again, we're here to help with that. I think there are a lot of people out in this community that are looking at metadata and work with metadata for a long time. And so if there are questions, please don't hesitate to contact us or contact Jen and bounce these questions off us. And if we don't have the answer, we will certainly try and come up with one and get back to you and sort of figure out a way that we can make that transition a little bit more seamless. So, again, the overarching goal here is let's, facilitate an international platform and a language agnostic exchange of data around the world as part of Goose, adhering to FAIR principles, We've decided we're going to use a NetCDF format. NetCDF's, pretty standard these days. There are changes to it, but essentially it's a standardized format that has been in use for a number of, years, decades, whatever. And that, more importantly, or maybe most importantly, is the goal here is not to develop a new format so that you have to write new code. It is to be able to use existing toolboxes that are out there, and there are a number of them that are very good, that allow you to pull in, NetCDF data and get it into, pandas, or get it into an Xarray data set, or whatever language you're using. And our intent is to not break any of those, and to make sure that this new format is something that can be used with the existing toolboxes, to help you, ultimately get your research done. So this is more of a plot that sort of describes that second bullet, right? So the idea here between, this evolution of existing data standards and conventions, we taking, and the DACs have done this years ago, is we take sort of existing, specifications, or community accepted standards. We use those to develop a data format or a file format, which has been done by the three DACs that are out there. And then ultimately what the data management task team really talked about is, well, these three formats work very well for what they're doing. And for the goals that we had and we set out, they do the job. So there's no reason to do anything radical here, to change, to get to a new sort of single format that would allow this international exchange of data. So that's where the ocean gliders really, I think, sort of developed from, is we take accepted standards, we use those standards to define some specifications that we know work and that serve the purpose for which they were designed. And then let's take the good parts of those, let's combine them and come up with, an Ocean Gliders 1.0 format that will help in this effort. So sort of very quickly here, a little bit of a comparison, sort of the main sort of highlights here on what I see as I sort of work through the specification, at least. And I'm focused on the DAC here. The other two DACs out there, I'm sure, are working on, something similar to this. So mostly what I'm talking about here is really coming from a comparison of what exists at the DAC, the IUS DAC now, versus where we want to go, or how we're going to get to the OG 1.0 format. Right. So the fundamental difference I think that we really have is the IUS Glider DAC is an aggregation of individual profiles where you have a single NetCDF file per profile. And those are combined into what we'll call a trajectory profile data set. So it's a trajectory of a glider moving through the water, but it's those vertical profiles, right? So those are being aggregated together. There are separate real-time and delayed mode data sets, right, where the real-time is updated as new data comes in. The delayed mode data sets typically are processed in batch mode, where you're pulling the flash card or the glider gets recovered, and then you're running your QC and all of your sort of fine-grained quality control, algorithms and things like that, and then submitting that data set in one big batch job, which it's picked up by the DAC, moved to NCEI, and that whole thing. In regards to how that differs from the OG 1.0 format. So the fundamental difference is the OG 1.0 format, instead of focusing on profiles, it focuses on the full trajectory. And for a trajectory, in this case, I'll talk about it sort of as it is. It's really a time series. And so I'll show you a couple plots here that I think will illustrate that a little bit better. But the priority really is for a single delayed mode data set where you've got data that you're aggregating to. And then there's a spot somewhere that we can go via ERDAP or via whatever the data server is, that the end users that are going to come in will then be able to take. They can subset out the information that they need and pull it without having to grab the entire data set all over again and waste all this overhead and bandwidth and things like that. The 1.0 format certainly is richer in metadata requirements than the IUS DAC specification. So I'll get to some of the specifics of that here as we move forward through the slides. And a lot of that metadata, we focused on encapsulating that metadata through the use of controlled vocabularies, right? Where a controlled vocabulary is essentially, let's take, for example, the glider models that are out there. So there are controlled vocabularies out there. Then rather than me call this a Slocum old glider platform, it would be, Slocum version 1.0 platform. It's got a bunch of rich information there contained. It's typically denoted by a link, where you've got a permanent link that you can specify as an attribute to these variables that will then allow you to go in and really provide a comprehensive view of both the platform or the instrument or I mean, you can name it. There are control vocabularies for just about everything out there. And so with that work, the work that goes into these control vocabularies cannot be underestimated. It's really a valuable service, and it's something that we're looking forward to really embracing, because I also think it will help sort of clear up a little bit of disconnect sometimes between, like, well, what glider are you running here? Or I'm running this glider and it did this. And well, we're going to try and provide you that information so that we can start answering these questions and feel good and confident about those answers. So next two slides, these are just talking about sort of the differences, right? So the fundamental difference really, so the glider DAC data sets are a trajectory of profiles. So you've got a single profile as a netCDF file, and then as new profiles come in, you are adding them to the data set. They are aggregated into a trajectory profile data set. So I guess a consequence of this is for right now, what the DAC serves are vertical profiles. So we understand that with the technology, as it's the glider technology, there's these opportunities to use a thruster and maybe fly horizontally, or you're on the surface and you may have your CTD on and you're drifting and things like that. And maybe some of that information is useful. Since the focus for the IUS DAC was initially GTS vertical profiles, getting those things released, we just focused on the profile. So some of that information may be missing. We're not, it's not a hard, like, no, we can't do this. It's just how we're focused right now. The OG 1.0 netCDF format, again, rather than the individual profiles, you're looking at what we're calling a segment, right? A segment is one or more series of dives, including surface drift, or if you're down under the water and you use a thruster, and maybe here, instead of going up and down, you may be going horizontal here. We do recognize that there are use cases for those. People are coming up with all new ways of sampling using the gliders. And so I do think that the OG 1.0 format, it certainly does address this. And so the question is for each of the individual DACs, how much of that information is going to be included in the 1.0 format, but it certainly does provide the mechanism for including as much of that vertical and horizontal information as you would like to. And again, just to talk a little bit more about control vocabulary. So I explained this a little bit, but control vocabularies, they provide the proper linking of platforms, instruments, standard names, and units to geophysical parameters. And they're standardized, so they make cross-platform exchange, I think, significantly easier, certainly more consistent, and probably more accurate. They are self-documenting for the most part. And I put some examples of the vocabulary collections that I typically, as a bit of a metadata nerd, spend some of my time going through and kind of taking a look at and making, okay, I want to use this or use this. So these three have really been fundamental for me in understanding the control vocabularies and their use, and a lot of the work that goes into creating them. Because again, it is quite a task to create these control vocabularies and get agreement on them, so that they ultimately are useful to the community. Because if they're not useful, then we really don't. There's no reason to spend time using them. So again, sort of doing a bit of a comparison, a high level sort of look here at the some similar variable types and examples between the two formats. So I think the take home message here really is that there's nothing in the IUS glider DAC or the OG 1.0 format that are not cross compatible, right? So there's no Essentially, we're using all these variable types. We have a trajectory defining the name of the data set. We have string variables. Both formats have string variables that specify things like serial numbers. I believe actually this is mostly OG 1.0. So the DAC format uses an empty platform variable and assigns attributes to that cover a lot of this, the serial numbers, the make models, WMO IDs, things like that. For the OG 1.0 format, some of these have been broken out into their own NetCDF string variables that, you know, again, it's 6 of one, half dozen of the other. All of the information that's there is accessible. It's just accessible in two different ways. And you can make an argument as to whether I personally don't think either way is better necessarily than the other. It's just a different way of doing things. There are scalar variables as well. Things, for example, things like in the OG 1.0 format, we want approximate deployment latitudes and longitudes. And we also are using what we'll just call empty scalar variables for capturing instrument and payload metadata. So, for example, if I've got a glider with a CTD and a chlorophyll sensor, I potentially would have an instrument CTD variable that just has attributes on that are, let's say, serial number of the CTD, make model of the CTD according to the control vocabularies, calibration dates, right? That kind of information that really allows you, if you need to go back and really do some, intense sort of, inspection on the data set, it provides all of that information. And then you would have a instrument chlorophyll A variable that has the same thing, where those attributes specifically relate to that specific instrument. And again, calibration dates and all that sort of stuff. So there aren't a whole lot of, the point of this is to really just let you know that there aren't really any fundamental differences. It's just sort of a little bit of some changes in how things may be organized between the two systems. So what does this mean for data providers? The good news is, I think everybody would agree, is that, we do, the OG 1.0 format does, as a lot of these formats have, you sort of break these things up into required, suggested, and highly recommended variables, attributes, pieces of information. In going through and comparing the two formats, I do not see any significant required additional metadata on top of what's already being provided to the IUS DAC NetCDF specification. There are things under suggested, and highly recommended that ultimately we'd like to get to, but I think we're going to focus on required first because we want to get this, a standardized data set there. And then as time and resources provide, we'll start building upon those with, enriching that information and just with the ultimate goal of really getting as complete and as accurate of a data set as we can, right? We have some things in the 1.0 format that relate to hardware descriptions like GPS and maybe Iridium, telecommunication type and things like that. And there's a strong emphasis on linking the instruments and sensors to platform and geophysical parameters. And again, a lot of this is through the use of attributes specifying, that instrument CTD variable can be used as an attribute on temperature to let you know that temperature was measured from this CTD. So if you think there's an issue with the temperature, well, what was the calibration date? What was the serial number? Can I go back through the history and kind of figure out maybe where the discrepancies are coming up? As far as our responsibilities, the IUS Glider DAC responsibilities, I think that what, the general plan here is we'll continue to accept the DAC NetCDF files with really minimal or no changes to the existing format. Most of the additions will again come through metadata, and that's just sort of taking the time to gather that information and include it. As I see sort of a high level approach to how we will take those, we'll continue to accept data sets to the DAC as we do. The goal here is that we can then take those data sets and we should be able to stitch those data sets into this trajectory data set that the OG 1.0 format, ultimately is. With that, we lose, I had mentioned this idea of a trajectory versus a trajectory profile. So The OG 1.0 format gets rid of the idea of indexing things by profile in terms of NetCDF dimensions. But that is replaced with the addition of what we'll call a phase variable that denotes the dive, climb, hover, and drift phases according to the EGO specification. So the EGO specification is what we're going to use. It's been out there for a long time. It serves its purpose. So we'll essentially be adding that in, take those profiles, we'll build up this phase variable, add the phase variable to the data set, and then we'll be off and running. We will be doing this aggregation and modification and addition of metadata via ERDAP into a single NetCDF file that allows for subsetting. Again, just to really minimize download overhead and bandwidth. As I mentioned, there's a detailed, I'm working on a detailed comparison of the two formats right now. I will have those done here, I would say, within the next week. And I would like to get those distributed to the UG2 community, as well as, anybody who might not be on this call for feedback and ideas prior to us. Our goal is not to come in here and tell you how to do things. We recognize, the experience and the years that you have all put into this. And we certainly want to take that experience into consideration when we're trying to figure out, ultimately, the goal is to make this as easy and non-intrusive on you. And we believe that, that providing that feedback and these ideas prior to plan and development and implementation will help us come up with an implementation that we think will work for the majority of the community. So again, it's, really what we're focused on here, I think, really is metadata management. There are a couple ways I think that we can go about doing this. That we will need, some contributions from our existing data providers. I came up with a couple here just off the top of my head. We're not committed to any of these. I just wanted to throw them out there to maybe get you thinking on these, as well as maybe some other ways that you might, suggest that we do this. But option one is, putting a lot of this responsibility on the data providers. I, as a glider operator, recognize that there's a whole lot of stuff going on when you're getting ready to put a glider in the water. And a lot of times the consequence of that is some metadata slips through the cracks. We're very aware of that. I sympathize with that. I think it's probably very common. So I do think that potentially it may not be the way that we really want to go about this. We do have tools in place now that allow data providers to modify metadata once with the NetCDF files without actually changing the NetCDF files. So that sort of piece is already there. The hooks are there that we can sort of clamp onto and as we're moving forward here. Option two is we've been kicking around this idea of the development of a web-based application that allows data providers and the DAC administration team to add, modify, and delete metadata to data sets that have been registered and have been submitted. I think if we were to go down this road, one option is a web-based application where you've got your user credentials, you log in, you go to your data set, and you say, I forgot to add the instrument CTD and calibration date or serial number. Let me just go in, click on the instrument CTD, put in the date, hit submit. That information then through the hooks that we already have there, then goes around and makes those modifications to the data so that you don't have to go in and rewrite NetCDF files and resubmit and do all of that, right? So if we are going to go down the road of option two, what I would really like to stress, and the DAC team has stressed, is we would be looking certainly for volunteers to help with the design and testing of the application, right? We don't want to build an application that makes it harder for you guys to do your jobs. You've got a ton of stuff to do. We're very aware of that. The idea is to make all this stuff easier. So if that is the route that we would want to go, again, it would be, and I know I've talked to some people, offline, who have expressed an interest in being sort of the guinea pigs here. And so I will certainly would approach them, and anybody else who would like to be involved with this, I think we would all welcome you know, as many test users as we could get here as we're developing this. Or are there other options from the glider community that we're not thinking about, right? Are there easier ways to do this? I don't know. There might be. And we're certainly open, you know, to listening to those ideas. And then our goal, I think, really is to, you know, within the next few months or a couple months here, is to come up with a plan to decide on an option, come up with a plan, and figure out how we're going to implement that plan given the requirements. And if we can get there within, you know, a couple months here, then I think we can, you know, we should be able to, you know, hopefully get working on that here under the next, you know, round of funding, and hopefully have something up and running here within the next, you know, year, funding year, I guess is what I would say. So that's about it. I just wanted to thank you, you know, again, to everybody, to UG2, the International Glider Community National Data Buoy Center, for their help with the GTS work, NCEI for data set archiving, the Ocean Gliders Data Management Task Team. That's largely a group of, we're largely a group of volunteers. There's been a lot of work and a lot of calls that have gone into that, the development of that specification. And we really do, you know, appreciate all the hard work that everybody's done on that, as well as our glider manufacturers. So with that, I will stop, and if there are time for questions, I'm here to answer.
Yeah, thank you so much, John. We do have time for questions. So if anyone has any questions for either John or Jen, please do either come forward and you can ask your question, or you can put the question in the chat.
Thanks, John. I really enjoyed that presentation. Yeah, this is Jen from the Spray Glider program.
Hey, Jude.
And you pulled up a dashboard display that showed the glider track and the metadata. And I think I have a link to that interface. But is that connected somewhere to like my deployments that I register in the DAC, or is that a separate link that like
Yes.
I need
So,
to be part of?
Yep. So it's a separate. It lives in a separate place, right? So it's glider.iso.us/status. All of the information that goes into building those status displays comes directly from ERDAP. And what I tried to do here is, particularly on the right side, is there are, I guess it goes one way. So, you know, here's my data set. If I want to go to the deployment registration page, there's a link to click. There's a link to click on the deployment registration. That'll take me to that take you to that registration page, or a link directly to the ERDAP data download page or the plotting page. So it's kind of connected mostly in one direction, versus like there aren't right now, there's not it doesn't go so much from the registration pages to the status page. It mostly uses the status page as the jumping off point, and then from there finding the data, searching and finding the data sets you want, and then being able to sort of go in and you know, take a look as you would like to.
Okay.
Thanks, Jen. Any other questions from anybody? I see that you have a volunteer already in the chat, Johnny.
Perfect. We'll take them. We'll take all the volunteers we can get. And I guess I don't know, you know, on that subject. I mean, you know, Georgia, I guess maybe we can talk about this, but I don't know the best way to maybe collect that list of names and then get it to us, so that we make sure that we've got everybody who wants to participate and we're not missing, you know, we don't miss anybody. So maybe we can figure out, I don't know if they maybe submit to UG2 and then we use that to create a list, and then we access that list and we can go from there, or whatever you think, or, you guys think is the best way to just, I don't want to miss anybody. So we are, we are a small team, and we certainly can use, the help. So if there are people out there that are willing and want to help, we want to take advantage of that for sure.
Yeah, that's something we can definitely talk about, and find a way to make sure we don't, miss anybody for that. Any other questions? This means that you guys did a great, great job presenting all the information. All right. Well, if there are any other questions, please do just pop them in the chat, but we can get ready to wrap up. So before I start wrapping up, I just want to say again, thank you so much, John and Jen, for taking the time, pulling those great presentations together and sharing with everybody. And if anyone has any questions, then please do, reach out to either them or myself, and I can pass those questions on. I guess just to sort of wrap up today's webinar, we will have another webinar in May. Topic is to be determined still, working through some different options for that. But as always, if anyone has a topic they really want to have sort of highlighted and showcased in this webinar format, please do email me with those suggestions. I really want to make sure this webinar series is useful to everybody and sort of the needs of the community. EGO also has a webinar series, and that is the alternate months to hours. So I believe their next webinar will be next month. And we also share those through our Slack channel just to promote them as well. So keep an eye out for those. Jen gave us a great shout out. UG2 does have some Slack channels. It's a really good collaboration tool. It's very dynamic. So if you're not already registered to the UG2 Slack, please do register now. You can either follow this link, the QR code, or register via our website. If you have any issues with any of this, please do email me. I definitely want to help as much as I can to make sure everyone can access all of these different platforms and tools. The website is another great tool. We are planning to relaunch the website in April. We have done some sort of revamping with the subfocus group for that. So keep an eye out for that. That is also where we will be posting a lot of the updates for the workshop in September. And one last thing about the workshop, we are working very hard to come up with some great themes and topics for the upcoming workshop based on that expression of interest form that was sent out. If anybody does have any final thoughts, themes, topics for this, please, again, send me an email. We are trying to make this workshop really useful for everybody that is planning on attending. So please always send me an email. Always happy to help. That's my role for the UG2 coordinator. So any themes, then please do send. We're hoping to come up with a great list based on those suggestions, ready for registration in April. So with that, I just want to say a final thank you again to everybody who has joined today's webinar, and to John and Jen for those great presentations, and hope to see you all in 2 months.
All right. Thank you, Georgia.
Thanks, everyone.
Thanks.